Hi, folks. Welcome to another episode in our Clean Code with AI series. In our previous episode, we had shown you how to use AI assistants when you work with greenfield apps, which means from scratch. In today's episode, we are going to cover how do you leverage AI assistants when you work with existing code, which are also called brownfield apps. Okay, let's get to it. I'm going to share my screen. To do a quick recap, in the last episode, we had built a rock, paper, scissors game. We had done test driven development and pair programming. Here you can see the tests, what we call a round, which happens between two players. I'll go into presentation mode. So the first test reads player one should win with rock. So when player one plays the rock hand and player two plays the scissors hand, then we expect that player one wins. And so the tests go on, covering wins of player ones and player twos with each hand, and also when the game has to be drawn, if when both the players play the same hand. Yeah. Now, how does the player class look? We have modeled a null object pattern in line 2. If it's a draw, then you get the player dot none. Let's go and see that in the test, which is here. Yeah. And there are two methods, one to check if the hand defeats the other, and another to check if it draws when it's the same. There is also a toString method for us to examine the player content in tests. How does a round look like? There is a winner method which takes in the two players, and it has a logic to check for a draw or for a winner. And lastly, we had the hand enumeration, which contained the three possibilities, and also a defeats method with some conditional logic. Yeah. Now let's run all the tests. Let's pull up the tests and run them to ensure all the 9 tests works. I'm going to show them to you as well here in my test runner. Those work. Cool. So code is good. We could actually go to the next feature enhancement. Um, Also, it's an opportunity for us to look at the object modeling, look at what can be refactored. And quickly, refactoring means that you are improving the code by removing code smells and doing better object modeling without changing the functionality or the behavior. So let's do that now. Let's examine the potential code smells over here. Um, this line may look harmless, but it is fairly complex conditional logic, and it could quickly get out of hand when you introduce more combinations. You may have heard the Big Bang Theory TV series, in which they play a variation of this game by introducing Lizard and Spock. So when that comes in, certainly you would need to come into one single place and then make changes. So I think one opportunity for us is to replace this with polymorphism, because you have specialized or different behavior um, uh, per hand, and that could be encapsulated better there or like overridden better there. Yeah. So let's invoke the AI assistant and give a prompt to say replace conditional logic with polymorphism. Right? Let's see what answer it generates. You can typically expect, yeah, this is IntelliJ idea, by the way, and it's up here slightly. And this, I'm also using the JetBrains AI assistant. And for people who are curious, I'm sticking with the O1 mini for now. There are other models that you could use as well. So it gives you the code, slightly harder to see here. I'm going to paste it to the main window very soon. And it also explains the code changes, and it should explain the benefits as well, usually, else you can prompt it again to talk about why things are better. Uh, right, let's replace this code with this. Let's format and run all the tests so that we know that our change is actually working and did not break any of the existing functionality. Because remember, this is still refactoring. We are not adding any new functionality. Yeah. Let's collapse the AI assistant. You may think that why did we choose more classes and the earlier four was actually simpler. Yeah, don't be afraid of classes. You should look at methods. And if the methods are small, typically 1 to 3 lines, those are awesome. And like I said earlier, any newer entries coming in here is going to override its own logic. And that's actually good. So how this has been done in Java, yeah, enumeration, it has put a abstract method and it's implemented or it's overridden with the specific hand. This looks good. Yeah. So let's go back and look for more opportunities to refactor. Now I'm going to the player class. Yeah, this again looks good at the outset, like we spoke about earlier. One side effect, though, in the unit tests, if you see, which brings in the contract, is that there is no value object here because the equality is based on the actual reference and not the content or not the fields of the object. So let's do that. Let's inline this. Yeah. Let's use a shortcut to run this. And now, yeah, if this player plays rock, then we expect the same player to win. The only difference is we are creating objects freshly. Let's see if this runs. Expectedly, this should fail because we are comparing the references, right? And not the content. So let's go back to player and quickly override. I was waiting for the AI assistant to prompt. It does prompt as well sometimes. So we can go back to refactoring and override the equals and hash code methods. Should be in. Now let's run the tests. Or the test should pass. Remember, we need to go back and refactor the rest of the tests as well. I'm going to um, expand all the tests. And now let's start inlining here quickly. So you will see the power of refactoring coming into the picture. When I say refactoring from the ID, right, this is not AI assistant yet. So makes it easy. I don't see any other variables. I'm going to run all the tests, all the 9 tests pass. So this was one more refactoring that we took care of quite quickly. That is great. And you can also see the number of lines of code also decrease. That's always a good side effect. Removing code is as important as writing code. Yeah. Now let's again go back to player and look for more opportunities. One inconsistency that I see is while hand handles defeats delegated by player, the draws is still handled by players. So let's delegate that as well. Yeah. So say draws goes into hand. Yeah. And let's introduce the draws method in hand. It should not be the default implementation. Yep, AI assistant has helped us with auto completion. So let's take that because it looks clean and correct. Expectedly, all the tests are passed. So this is one more minor improvement. I still acknowledge that yeah, player is delegating its logic to hand, right? And the only data and behavior of it is being a value object. So that's one potential thought that we can entertain in the future if this is the pattern that you like or is there something. But for now, I think it's good. So let's leave this here. Let's look at more opportunities. So let's go back to the tests and keep examining our contracts because that is where we get the hints. So if you actually think about domain-driven design, right, and you can actually visualize how this game is played between two players, and they do a countdown and they show the hand. So it means that we need the players first, right? We don't need the round first. So that's one hint that you need players first. And also players change hands. Players don't only live with one hand choice all the time. So they should be able to pick hands. So with that in mind, let's change the identity of player from hand into a name because each player will have a name that doesn't change. So let's go back to refactoring, change the signature of this method. So this is going to help us actually maintain the code to compile and not break everything because this is existing code. Remember? So we need a name of like a field name of type string. And for now, the default value can be player one. I expect test to break, but I just want to pass the default value. So it becomes zero. And now, actually, we can remove the older uh, hand parameter and that should only be the name. Let's do this refactor. So now you see that all the players get instantiated with player name. As of now, let's only focus on the first test and get to pass the first test. Right? Let's go back to player and see if anything is not compiling as expected. We are not setting hand, so it is failing, and we don't have a field for name as well. So let's create a field. It's correct. Let's move it up. There is no hand to set yet, right? So we cannot set a hand, but if you do not set a hand, it would shout at you for using something which is not set, correct? So what do we do? So what we can do is, let's do this. We should go back one step. I'm just thinking. I cannot really hard code this. Maybe I was too ambitious to uh, remove this method from here. So yeah, maybe that's okay. That's how we learn, right? So you come back here, go to refactor. Let's change the signature again. Let's not be too ambitious. So let's take smaller steps. So let's call this as type hand. Let's reintroduce it. There's no default value for this because we are going to set it from inside. Maybe, yeah, I think for it to compile, let's call it as let's refactor. All right, so now it looks like it's happy. Let's focus on the first test, right? Uh, write a bit. Player two should continue playing scissors for them to lose and for player one to win. So now let's go back into player and figure this out. Yeah. Um, I don't know why this has happened this way. So now the player has a name and the player has got a hand. Uh, this looks like improvement. So let's run all the tests and hopefully the first test is going to pass. But yeah, it looks like all the tests pass because yeah, I think I have made the tests a bit meaningless and that's why all of them are passing. But that's not the correct feedback. So let's list the tests and ensure that the very first test, right, this is passing. So I think that is good. Uh, but at this point, we need to start looking at how the players can pick a hand. Right? So now I'll do something a bit counterintuitive, but again, that is to maintain the sanity of the code. So let's introduce variables calling as player one, because I just remember that we removed this to bring in the value objects, but let's add it back and you'll quickly see why. Because this is now going to go away and then the player is actually going to pick a hand, right? Because that's how it like needs to work. So player one, pick rock. Yeah, let's compile this. Yeah, it just has a name. So this is the constructor that we want to eventually get to. Remember that I tried to do this and it backfired. But yeah, maybe I'm just showing you that how it can be done in smaller steps. So now let's introduce one more variable here for player two. Again, let this use the new constructor. I move this up one line so that we start creating the players. Then they start picking the hand. Now player two will pick the hand of scissors. Already, I think it should look a bit intuitive to you. Right? So this is how it should actually be. And then that's a good thing. So, sorry, I have a bit of a sore throat today. Now let's set hand once the hand is picked, right? Not when the player is created. So that's the right modeling. It's shouting because hand is final and we'll quickly change that. Let's move this up so that the order is retained. It's easier to read code. Let's make hand not final because it can change to the custom. Right. Anything else? Will it run? Will it compile? Yes, it does. And still the first test passes. I think that's what I care about now. And now I'm starting to move these things up maybe rather first let's move the players up. And now, if you look at round, right, you need to construct a round with players. So that makes more sense. So let's do that. Let's change the constructor of the round to actually take players. They don't exist. So let's add the fields final because they don't change. It's good. And once this happens, like everybody else shouts at us because it's not there. So for that to be happy, again, let's do the double click and just say, yeah, let the other thing exist as well. Right? Uh, because then the code is going to continue to compile. But still, let's retain the focus on the first test. Yeah. And if that's the case, maybe we need one more method or modified method called play, which doesn't need players because the round is constructed with the players already. Yeah. And the players have picked their hands. That's good. So let's play. What does play do? So play essentially does what winner does, right? So it actually calls winner, but I'm just going to copy paste it here as of now, but we could actually invoke winner as well. But I know winner is going to go away, and that's why I've done this. So let's run it. Okay, something is not working. Happened. Um, right. It said now it's saying that hey, player two is not initialized and player one is not initialized. How dare you use this? Right? So yeah, I think it's time to start refactoring with a faster speed. So let's go back here. And I think we can quickly replace the round anyway with this new constructor that we have, where we are constructing the round with the players and not just a empty round, which in hindsight doesn't make sense. Yeah, and that's how iterative, like brainstorming, thinking, modeling helps, right? And now with AI assistants, brainstorming is practically free, so always use that. So now the code should compile and the test should run. All right, all the tests are running, but yeah, you know that there are some false positives here, and that's why you just cannot trust all the tests blindly. You need to write good and clean tests. Yeah. But let's focus on the first test still. So player one should win with rock. We are constructing the two players. And then we construct the round with those two players. The players pick hands and then they play and determine the winner. Yeah, this looks good. Actually. Yeah. And now let's take a brave call because we know the pattern of all the tests. I'm going to collapse the test so that it's easier to delete. Let's delete everything. Right? And let's write it again because, yeah, we have the history and we know the pattern. And now once you do this, you wouldn't really need the dead code. So go and delete dead code again. Deleting code is good. Let's go to player. Let's see if anything is unused. Yeah, this first constructor should not be using here. See, that's smell because I hard coded it this way. So it should be. So, so sometimes, yeah, you do miss it, right? So you should be careful when you go and refactor quickly. And if you don't examine the contents of the null object, maybe you don't care, so it's okay. But yeah, at least for readability, you should maintain that same sanity. Yeah. So yeah, now the code is good. I don't see any dead code anywhere. Look at the round, look at the hand, looking at the player. Now, yeah, let's go back to test. Our code coverage has taken a hit because we've deleted all the codes practically. Let's now go and see if AI assistant actually helps us do this very fast. Yeah, I think we can see it. Jump a little further. I mean, not ideal because it's saying player two should win with paper. Yeah, but that could be a different pattern. But I prefer to be in the driver's seat and say, let's finish all the player one wins first. Not lose like the wins, or rather, yeah, I think let's stick with the hands. Okay? That's what we did last time. Player two should win with draw. I think now it gets it. It's able to construct the players and the round. Hopefully, it will give an extra line. As I pick the right things, yeah, player one scissors, and that is right. I want an extra line. We should expect player two to win now. That test should pass. Awesome. It's good. Let's collapse the test so we can continue reading it. And trying to get the AI system to come into play. Why? Well, let's teach it the pattern. Player one should win with paper. That's correct. Let's pick paper. Player two should pick rock. That's right. Big line. The arrange act as its pattern. Let's run this. On the test run, let's collapse this as well. Let's go to the next one. Let's repeat the pattern. I hope you can see how easy is it now, and I think the assistant is becoming better with every iteration. That's good. So we have covered now rock and paper. Let's quickly write the tests for scissors as well. Yeah, I think AI just needs the right nudge. Um, Take you to where you want it to go. Let's write two tests now. Feeling lucky. Uh, Layer two should be in the yeah, see, it actually gave the empty line as well. It's awesome. So let's run all the tests. You can see the number of tests. Yeah, okay, I'm surprised that it failed. So now let's try to see. Yeah, you can see that only one hand got picked. So it put the empty line, but it didn't put what the player two has picked. That's a good sign. But yeah, it's okay. Because we have tests, we can make these changes confidently. Cool. So all these winning combinations are done. Now let's go to the losing combinations. There is a new should draw, return none. Yeah, this doesn't make sense. It's test name. So let's write a correct test name. Say game is drawn, I think is what we have. When both players, let's be more deterministic. Pick draw. So, yeah, right. This is good, right? Yeah. So if by now, if you had um, used uh, like refactoring to move this into common helper functions with the testing framework, the AI would have picked that pattern as well. As you know, you can work with the assistant to get those things as well. So now let's say, all right, it is able to predict almost in the last level. Yeah, just need to nudge it a bit more. Yes, it's there. Okay, so now let's run all these tests. So we have back to our good old 9 tests, right? So with the refactorings now done, um, but I'm thinking there is more opportunity for us to extend the code because of the way the modeling is. Right? So let me start writing the test. I'm thinking to see if AI can read what I'm saying. Yeah, close, but we should say player one should win with valid hand when player two picks. Now, yeah, because maybe the countdown happened when they were playing and player two didn't pick anyone. So now it's pausing for me to start writing things. So I'll say, yeah, let's create player one. Okay, the competition has started. That's still not there. So let's create player two. Let's construct the round. I was hoping for better support in this one. So, because the model is very intuitive, we are able to type that one. Now, after this, right now, player one picks a hand. It could be any hand. Now, let's start with the rock. And now, let's say player two did not pick any hand. So now I expect that player one has to win. Yeah. Let's see if this test passes. Hmm. Saying, hey, I mean, it's a draw because I don't know what you mean. So that way we need one more and which is none. Actually. So because at this point, when you go to the play, it's playing with the hand that is not there. Yeah. So let's go to hand and yeah, no, let's go to player. Actually. Let's go to player. And then when when the player is constructed, the hand should be not chosen yet. Yeah, and only when the pick a hand is when the hand gets chosen. So doesn't exist yet. So we are going to create a enum constant. Yeah, and now we are going to enum, and this implementation is not there. So I'm hoping now AI is going to help me do this. Awesome. Saying if you don't choose a hand, then irrespective of the other hand, you lose. Great. Let's see if this score works. Still doesn't work. I think as you would have guessed, the player one has picked a rock, and hopefully now you can see how easy is it to extend the score. So if the other hand is not chosen, then return true actually, because it always defeats not chosen. Yeah, but it can be random now. So you go to the test and let's randomize this hand. uh, You can say new hand. Oh, cool. So it's able to understand what I'm trying to do, but it's constructing enum array of valid hands, but it's always picking the first one. So instead of that, let's randomize it. Not that random is on Java util, but random is not imported yet. Let's import that and let's say next int. It knows the upper bound is 3, which is exclusive. So you'll get a number from 0, 0, 1, or 2. And this can be a random hand. Let's see if you are lucky. You're not lucky because we played scissors. So let's go back to hand and we need to basically duplicate this code in paper because that could be random as well. And then scissors. Yeah. So it's guaranteed to pass. And let's do a bit of refactoring. Refactoring doesn't uh, like limit to only source code. Let's extract a method here, same as any valid hand. Yeah, it's better. And let's move this down. Logitech keyboard shortcuts doesn't work for some combinations. So let's move down here, run all the tests to ensure that it's working. Works. I think there is one more test remaining. If you have guessed already, I'm hoping the assistant is going to guess. Right, it has. The game should be drawn when both the players speak, not chosen. So, right, now it should be none if both are not chosen. It passes because of the logic. Great. So, in the effort to refactor code, we have discovered newer edge cases as well. And then, yeah, with the business approval, we have added that in. And because of the refactorings, it actually was easier to make those changes. It's great. I'm thinking, but still, this class, contrary to what I mentioned earlier, has got a bit verbose. So I'm going to take the AI assistant's help to simplify this. So I'm going to say chat using selection. Say simplify code by remove duplicate condition check. Yeah. Let's see if it understands what I'm trying to say. Like I said, brainstorming is now free, so please use a facility. Yeah, and you'll be surprised at the different implementations that you get, and you can always throw it away because AI is not input output, right? AI is like generated. You can keep working until you're happy. So I just want to see it better, so I'm going to copy it to the clipboard. I don't like this implementation because it's not done much. So I'll be a bit more directive now. I'll say use a static initializer log, right? And private and defeats with validity check. I've done this earlier, so I know where it's going to go. But eventually, when you do it yourself, right, for any logic that you're working on, you will figure out that there's an implementation that looks good. You want to keep that, like the one that has come Now the hash map. So let's take this, but I don't like comments because clean code doesn't mean comments. So I just say clean comments. Still running. Finish it. Oh, the alternate implementation as well. So does this work? See, says a compilation. So let's say in the second implementation. So this is how you have a conversation with AI, right? I get a compilation that reference to undefined numbers not allowed. So use a static log instead. Yeah, let's see if we get there now. Right, it seems to have understood the direction. See what comes in. I'm copying too early. Yeah, let's wait for gender. It's a lot of comments. Yeah, we need to train this that clean code doesn't need comments. So I'll do one thing. I can ask it to remove the comments, but because it's slightly slower in the way it's generating, I'm going to trust that this is generating the code, and I'll copy it and remove the comments. So, yeah, and I will do away with the AI assistant. Yeah, so we were here. Um, let's remove the comments. That's what I was saying, because comments are not clean code. Yeah. And some of you might recognize this syntax, right? So we still have the same enumeration, but we are using a static initializer to denote what hand defeats what. And we also put in not chosen in the mix, right? And that returns null because it doesn't defeat anything. And that's how the conditionals have been eliminated. So cool. Now the tests are passing. One more small refactoring that we can remove this brace so it looks cleaner. And yeah, this is what we have achieved today. So if you look at player has become a value object. Player is identified by name. And I think, yeah, maybe, yeah, one more thing, yeah, before I go. So we should regenerate these things because now the fields of player has changed, right? So let's regenerate toString to indicate to have both string and hand because we want to examine the contents. And AI is already counting. Let's go back. So AI says, okay, I'm going to give you um, the facility to override equals and hash codes, but I'm only considering name, which is awesome because name is the identity, right? So AI assistant has come into play. So let's see if all the tests are passing. They do pass. Also, last thing is if you know better, right? If you know where you want to go, so you can take AI there. And I know that refactoring equals and to string, like equals and hash code is a better implementation because it's better than what AI gave me. So I can put it back in. Uh, maybe the AI assistant is going to learn about it. Yeah. So player looks good. Let's quickly, we just saw hand, so we are good there. We will look at the round. Yeah. This looks good. We will do tests. Yeah, it's looking good. And we also added new functionality as well. So awesome. So yeah, that ends the refactoring kata. Hope you had some takeaways today on how to refactor with the ID refactoring shortcuts and also leverage the power of AI assistants. Keep learning, keep coding clean. Thank you, folks. Bye.